Audio Jungle.
Assalamualaikum to Dr. Arif and fellow viewers. We are from Group 5 and today we'll be presenting about Experiment 3 for Lab Report Fluid Mechanics Lab, which is minor losses in pipe. And this is our team member, which the first one is Muhammad Daniel bin Abdul Razak, the next one is me, which is Mahzumi bin Wasli, and the last one is Muhammad Dazan Aiman bin Mike Nazri. The introduction for this experiment is in fluid mechanics, the term minor losses refer to the loss of pressure or heat due to components in a piping system other than the straight sections of pipe. While term minor, these losses can significantly impact the efficiency and performance of a pump system, which particularly in complex piping networks. The objectives for this experiment is to determine the loss coefficient, which is the KL value, and the second one is to determine minor heat losses in pipe components of fittings for different water flow rates, pipe diameters, and pipe bends. For the scopes of this experiment, the first one is to set the volume of water collected to be 2 liters for all types of minor losses in pipes. Next one is set the volume for H1 and H2 for each type of pipes using the manometer tubes. And then we're moving with the determine the loss coefficient value by choosing the outlet valve as constant stream water for all types of pipes. And then last one is close the inlet valve to create water path for the desired minor losses in pipes to obtain the ready values of time, change in H and QX. The theory of minor losses in pipe. Minor losses are local energy losses caused by the disruption of the flow due to the installation of appurtenances such as valves, bands, and other fittings. The formula is Hs is equal to Kv squared over 2G, whereas Hl is equal to minor head loss in unit of M, K is equal to resistance coefficient, which the unit is dimensionless, V is equal to mean velocity, which the unit is m over s, and G is equal to gravitational acceleration, which the unit is m over s squared.
This is our experiment setup for experiment minor losses in pipe. We have inlet, we have testers pipe section, 2 tube manometer, outlet valve and manometer tube. We have 13 steps of methodology of this experiment, which is the first one is the direction of water inflow and outflow through the pipe was determined. Second, open the inlet valve of selected pipe section in parallel with the pipe. Next, switch on the pipe. Fourthly, slowly open the control valve, turn counterclockwise until maximum, and wait for a while in order to remove any air bubble in the flow pipe. The fifth step, identify which inlet flow pressure H1 and outlet flowing pressure H2 and connect to the manometer. Next, record the value of H1 and H2 in millimeter mm of the inlet and the outlet of water manometer. 7th step, record the volume water collect at the tank with the time of measurement of the flow rate Q of water. The next step, find suitable flow rate Q by adjusting the outlet valve was determined. Next step, after finish, took out the manometer tube first to avoid the bubble in the tube. The 10th step, open the inlet relate valve for the next pipe and close any valve which will not leak through water flow. 11. Repeat the step 5 until 11. For the 12th step, once finished, take out all the connected tube from the system and fully close control valve. And last step, switch off the pump and main switch. This is the result for our experiment. For pipe section sudden enlargement and sudden contraction, we use 2 liter for volume of water collect, and we record the time to find the QX, which is volume of water collect over time, and then we record the inlet flow pressure H1 and outlet flow pressure H2 to find the difference between inlet and outlet flow pressure. Next, for the pipe section Y type and T type, we also use 2 liter for volume of water collect and record time to find QX, which is volume of water collect over time, and then we record the inlet flow pressure for H1 and outlet flow pressure for H2 to find the difference between inlet outlet flow pressure. Lastly, for pipe section 2 time angle 90 degree, 2 times bend 90 degree and 2 times angle 45 degree. We also use 2 liter of volume of water collect, and then we record time to find the QX, which is volume of water collect over time, and then we record the inlet flow pressure H1 and outlet flow pressure H2 to find the difference between inlet outlet flow pressure.
For the data analysis, we need to calculate the minor head loss, which is HLM, and loss coefficient, which is KL, for each pipe component or fittings. Note for major losses, HL, calculation, we need to set the temperature of flowing medium, which is equal to 36 degrees Celsius, and determine the coefficient of friction using a formula of basis, which is F equal to 0.3164 divided by Z for RE. For sudden attachment, the formula that we use is KL equal to 1 minus AI1 divided by AI2 square. HLM, the formula is V2 minus V1 square divided by 2G. The loss coefficient for sudden attachment is 0.3713 and average minor loss head loss is 0.0026. For sudden contraction, the formula that we use for KL and HLM is same with sudden enlargement. The loss coefficient for sudden contraction is 1.2448 and the average minor loss head loss is 0.0026. For T-type, the formula that we use is different with sudden enlargement and sudden contraction, which is KL equal to 2D times by HLM divided by V squared. For HLM, the formula is still same, which is V2 minus V1 square divided by 2G. For the average loss coefficient, which is equal to 0.9969, and the average minor loss head loss is 0.0071. For Y-type, the formula for KL and HLM we use is same with T-type. The average loss coefficient for Y-type is 0.0072 and the average minor loss head loss is 0.0054. For 2 times angle 90, the average loss coefficient is 0.9977 and the average minor loss head loss is equal to 0.0045. For 2 times bend 90, the average loss coefficient is equal to 0.9981 and the average minor loss head loss equal to 0.0058. For 2 times angle 45, the average loss coefficient is equal to 1.0022 and the average minor loss head loss is equal to 0.0048. For safety procedure, first, always alert with the caution and handle carefully to avoid the pedal braking. Second, eyes must be perpendicular to the scale of reading value to avoid the parallax error. Third, make sure the manometers are fully connected to the pipe flow to ensure the flowing water to be smooth. Fourth, do not touch the switch with your wet hand and make sure you use with dry hand to avoid electric shock. For the effect of different water flow rates pipe bends on the value of loss coefficient discussion part. The equation for water flow rate Q equal to AV, where V is the velocity of flow in the pipe where the minor loss occurs. If V increases, the flow rate Q will also increase. The loss coefficient has no dimension since it represents a proportionality constant between the energy loss and the velocity head. The magnitude of the loss coefficient is determined by the structure of the system causing the head loss and the velocity of flow. If the water flow rate is high, the friction loss in the pipe is greater, hence the loss coefficient is also greater. When water flows from a smaller pipe into a larger pipe through a sudden enlargement, its velocity will decrease rapidly, causing friction and resulting in minor energy loss. The minor loss due to sudden enlargement of the pipe can be estimated by integrating the momentum. When water flows from a larger pipe into a smaller pipe through a sudden contraction, the fluid streamline will converge just downstream of smaller pipe known as vena contraction phenomena. It's creating a turbulence region from the sharp corner of the smaller pipe and extend past the vena contracta, which subsequently generates an energy loss. The smaller the pipe diameter, the more friction it will contain and more energy will lose. Hence, the higher the loss coefficient, loss in fittings such as elbow, valve, and others have been found to be proportional to the velocity head of the fluid flowing. The longer pipe bending, the smaller the loss coefficient. For factors that contribute to error or inaccuracy experiment data and the possible recommendation to improve the existing result discussion part. The factor contributing to error or inaccuracy in experimental data is a parallax error that will occur when the eyes are not perpendicular to the measurement scales. Besides, human errors such as mistaking data can also lead to calculation error. The presence of air bubbles trapped inside leads to mistake. The fluctuation of the manometer column head due to the unstable flow rate during experiment will affect the accuracy of data taken. Furthermore, the environmental factors such as vibration, temperature change, and electronic noise may influence accuracy of measurement. Hence, we need to take some precaution to minimize such factors to improve the accuracy of data taken. We need to make sure that our eye level is perpendicular to the measurement of scales during taking data to avoid parallax error. We also need to make sure that we take the correct data and repeat calculating to get the correct answer. Besides, we need to remove all trapped air bubbles by opening the ventilation valve to allow the overflow of water before experiment. To avoid errors caused by fluctuation of manometer column head, several readings should be taken and take the average reading of N to get the accurate HL, H1, H2 answer. Lastly, we need to make sure that the environment that we experiment is in a safe and quiet condition. In conclusion, the losses coefficient and minor head losses in pipe components are affected by the flow rates, pipe diameter, and pipe bends. Various types of pipe, sudden enlargement, sudden contraction, Y-type pipe, T-type pipe, 90-degree angle pipe, and 90-degree bend pipe, and 45 angle pipe we are used to determine the loss coefficient with different volumetric flow rate. So, the result shown that when the diameter of the pipe increases, the loss coefficient also increases as friction loss of a flow also decreases. However, when the flow rate of fluid increases, the head loss of the fluid and the loss of energy increases due to the increasing velocity. Therefore, the loss of energy and head loss also increases in the presence of pipe bends. The experimental value of head loss may be different with the theoretical value of head loss due to several factors that affect the experimental value of accuracy. Thus, we can reach the conclusion that the lower coefficient loss contribute to the high efficiency of the pipe system. The objective of this experiment is achieved as the loss of coefficient and minor head loss is determined through calculation.